When you run any experiment, we usually use statistics to compare the results between the two experiments. So if you have a sample and it's the same sample, and then you run two different experiments on the same sample to find the component or you run a quantitative analysis to check what is the amount of the component within your sample. Then you end up with a mean value and a standard deviation, which reflects the uncertainty of your calculation and of your measurement. So in order to compare our results, we need to do to run statistics. So statistics can either run for comparison of the mean value we found for the both measurement, or it can be for the standard deviation. So to compare to standard deviation, we usually use what is called the F-test. So the F-test is used to decide whether two standard deviations are significantly different from each other. So how to do this? We usually calculate something called F calculated, and then we compare the F calculated with one from a table. So there is a table that gives us the value of F at a certain degree of freedom for both the two experiments we ran, because both experiments could have a different number of measurement. And then we compare the F we calculated with the F from the table. So how can we calculate F? So F calculated equal the square of the first standard deviation divided by the square of the second standard deviation. So you have two experiments, you ran two experiments, and each experiment has a certain mean and a certain standard deviation. You look at the standard deviation, the two values of the standard deviation. S1 is usually the one that is higher in value. So S1 has to be always bigger than S2. So whatever, it doesn't matter which experiment runs first, it doesn't matter which one we write first, it's always S1 has to be the one with a larger value for standard deviation. So S1 squared divided by S2 squared. And then we calculate the F, and then we compare it with the one from the table. So if the F calculated is higher than the F from the table, that means that there is a significant, the two standard deviation are significantly different from each other. So there is usually a certain degree of certainty here, so or certain degree of confidence or certain level of confidence. So if usually the F test is at 95 confidence level, that means that if the F calculated is higher than the F from the table, that means that there is less than 5% chance that the two standard deviation came from the same less than 5% chance of coming from distribution with the same population standard deviation. So they are both are significantly different. For example, here, if we are measuring the bicarbonate in concentration in horse blood, so we ran the experiment using two instruments, an original instrument and a substitute instrument. The mean value for both, the first one was 36.14, the second one was 36.20. The standard deviation for the first one is 0.28 and the second is 0.47. Number of measurement here is 10 for the first one, the number of measurement for the second one is 4. In order to calculate the F in this experiment, then the F would equal S1 squared divided by S2 squared. So S1 here is going to be the substitute instrument because this is the higher value. So it's 0.47 squared divided by 0.28 squared. Then we calculate and find the value. Then we have a look at the table. So the first one was S1 here was 4, a number of measurement was 4, so the degree the So the degree of freedom for the S1 will be 3. Here equals 3, and the degree of freedom for the second one will be 9. So we have a look at the table. Degree of freedom 3 for the S1 and degree of freedom of 9 for S2. So you look that in the table, you find it's 3.86. So you compare the F you calculated with the 3.86 from the table, and then you can find if it's significantly different or not. In this case, if we run the calculation, you will find that the F calculated in this case, the F we calculated here will equal 2.8. And as you see, the F calculated here is less than the F from the table, because F from the table is 3.86. That means that these two are not significantly different, because the F calculated now is less than the F from the table. If it was the other way around, if the F calculated was higher, then they are both significantly different. This is how you compare two standard deviation with each other.